So let's suppose we have un is equal to n to the 4 plus 5n squared, all divided by n cubed plus 4. Okay, all divided by n cubed plus 4. So, how are we going to test whether this is convergent, divergent, or periodic? We do our limit test, right? So we take the limit as n approaches infinity. In other words, what happens as we consider more and more terms of this thing? Okay. Well, let's think. We consider the numerator and the denominator separately. Okay. What will this thing start to look like as this gets ridiculously big? What's going to grow faster on the numerator? The n to the power 4 term or the 5n squared term? The n to the power 4 term, right? That thing will clearly grow much, much quicker than that thing. Are you happy with that? Because you're raising it to higher and higher powers. So in general, the higher power will always shoot off much quicker than that one. Like that will still get pretty big, but that one's going to grow much, much quicker. Okay. So it starts to look like n to the power 4. On the denominator, which term is going to grow? Which term is going to shoot off to infinity? Yeah, the cubic term. Like eventually, adding 4 will not make a blind bit of difference. Okay. So this thing will start to take on the characteristics of n to the 4 divided by n cubed. And if we just do a bit of tidying up, what's this thing equal to? It's just n, isn't it? Because n to the 4 divided by n cubed is just n. Yeah? Now, what do we know about n? As we consider more and more terms in the sequence, is this convergent or divergent or periodic? It's divergent. Are you happy with that? Yeah, as you put in bigger and bigger values, this thing's just going to shoot off to infinity. So therefore, this thing here is divergent. Is that all right? Yeah? Okay, try this one then. By the way, you don't have to call your sequence u. You can call it whatever you like. I'm just sticking with u. All right? So let's try. What happens to this thing? Convergent, divergent, or periodic? So we'll do a limit test. What happens with this thing, do you think? I suppose the question is, what's going to grow quicker? 3 to the n or n squared? Right, okay, good. So in general, what grows quicker? 3 to the power of n or n squared? 3 to the power of n. Like it might start off that this one is quicker to start off with, but eventually this one's always going to get bigger. Like an exponential, where the variable is in the power, is always going to shoot off much, much quicker than a simple polynomial, where the variable is being raised to some power. Okay? Are you happy with that? Yeah? If you're not sure, you can always stick some values in and see what happens eventually. Okay? But are you happy that this thing is going to approach or take on the characteristics of 3 to the power of n? Okay? So my question is then, 3 to the power of n, is that convergent, divergent, or periodic? I would agree with that. That is divergent. Is that okay? Yeah? All right. What about something that looks like this then? Let's suppose I have a sequence that looks like n times by n plus 4, all divided by n cubed. What do we reckon? Convergent. Okay, how do we know? Good, so you've expanded the numerator out. So we get n squared plus 4n over n cubed. And then we're just back to this idea. We just take the limit of that sequence. By the way, you must write down the limit of the sequence. It's the notation which you need to use to show what you're doing here. So the limit, as n approaches infinity, of this thing. Okay? Well, let's think. As n gets bigger, what's going to dominate on the numerator? The n squared term or the 4n term? N squared, perfect. And what's going to dominate on the denominator, it'll just be n cubed. You happy with that? So, tidy up, what do we get? 1 over n. We're back to that thing again. And we know that 1 over n converges, yeah, as n gets bigger and bigger. Okay, so therefore, this thing here must be convergent. Okay, must be convergent.